Hello, this is Shiksha Vinay, and I am going to deliver the lecture upon Kinematics, Part 11, for Study 9. I have discussed the trigonometry in the previous lecture. Now, I am discussed here that how can we express the perpendicular line and base line by using trigonometry. So here, this is a right angle triangle ABC, right angle at B, and for theta of consideration, AB is perpendicular and BC is base and AC is H. Have you got my point? So you can write sine theta must be P by H. So by cross multiplication we can write P is equal to H into sine theta, and in the similar way we can write B is equal to H into cos theta. This is very useful relationship which we take it in the study of vectors. So now I come back to our important discussion, how we add two vectors. So you know that the vectors is the physical quantity which has magnitude as well as direction. So here there is a point on which two vectors are acted. One vector, which is A vector, is acted in this direction with some magnitude, and the another vector B vector, which is acted on that point in this direction with some magnitude or some value. So how we add these two vectors, or we can say what is the resultant or combined effect of these two vectors on that object. I have already told you in the previous class, if a boy kick a ball by 3 Newton in north direction, and at the same time another boy kick a ball by 4 Newton in the east direction, what will be the combined effect of these two vectors? How can you find it by mathematics? So first of all, I am giving you some method how to find out the correct result by some manipulating the mathematics. So if the two vectors are applied on this point, then you must have to take these vectors that the initial point at a single at that object. Means here is the arrow represents the head of the vector, you can say head of the vector, and the initial point is represent the tail of the vector. So in a vector, the head is on the arrow side, and the tail is from where it originates or from where it comes. So tail is here. So in this way, this vector head is here and tail is here. So what you have to do is that you have to take the tails of these vectors at a single point or at that object upon which they are acted. So I am taking the tails of these two vectors. Remember that don't change this vector by changing its direction. I am taking this vector at this. So in your mind you can say that will the vector not changed if you displace it from here to here? This may be the natural question. So for this I am giving an example. If I kick a ball at your home in a north direction by the impact of 5 Newton, and if you kick a ball on the playground in the north direction by the same impact 5 Newton, what will be the resultant of these two cases? Are they same? Yes, of course they are same. It will move or it will go with the same impact in the same direction as in your home. That's why a vector when place is changed, vector does not change if you keep the direction of the vector and the magnitude of the vector same. I am taking 5 Newton in your home and in the playground. I am taking the direction north and north. So these two vectors are equal vectors, whether they are performed at your home or in the playground or somewhere else. So if I displace the vector without changing its direction and magnitude, we can take it anywhere on the paper. Have you got my point? So without changing this direction magnitude, I displace this vector here, because we have to take its tail on that point. So I displace this vector. But a vector has already the tail on this point. So both the tails are now here. These kind of vectors are co-initial vectors. Means the initial point coincides at the single place. Then these vectors are called co-initial vectors. And the second point I have told you that a vector can be displaced anywhere, keeping its direction and magnitude. You can also say in another way that a vector can be displaced parallelly with the same magnitude. Parallel vectors have same angle, so the direction is same, and if it has same magnitude, then the vector must be same. Yes or no? So B vector can be taken here, B vector can be taken here, B vector can be taken here, no matter, but keeping the magnitude same, and these are parallel. Yes or not? Because the direction is same, so they are parallel. And if its magnitude and its magnitude is same, means they are same. They represent same vectors. B vector here, B vector here, B vector here. Are you getting my point? So for solving our problems, we can displace it as per condition needed. Now for the addition, first we have to do is we have to take the tails of these vectors at the point of application. I have taken A and B. Now I have to draw a parallelogram. I am here. This line is parallel to this, and this. So the mathematics say that if we measure the value of this diagonal, it gives you the net effect or resultant value of these two vectors, combined value of these two vectors. It is strange, or perhaps you didn't understand it. Yes or not? So for your understanding, I am giving you some example. You can familiar with it. So here, let us say at a ball, a boy kick by 3 Newton and another boy kick at the ball by 4 Newton. Have a good moment. So it can be written as, because the head and tail are coincide, so what I have to do is we have to take tail and tail at the single point. So its tail is already at there. Now I displace this vector, and then now two tails are here. Now we have to draw a parallelogram. And the diagonal is this, so not. So the ball will move in this direction. And with what impact? If you calculate the length of this, you must got the real or actual result. So how we calculate? We know that if it is parallelogram, if it is 4, then it is also 4. And it is already 3. And it is 90 in this case. So by Pythagoras, we can evaluate it as hypotenuse must be 5. Are you getting my point? So we got the resultant effect is ball will move in this direction by the impact of 5 Newton. Have you got my point? This is so easy. But it is a strange way. So in your mind there comes a thought that why we are doing this. It is actually if you try to search something, try to find out some problem, how to solve it, then you manipulate some idea. You think that how we can try it out to solve the real problem and get actual problem. You solve it and you become fail, and again you solve it, you become fail, and the trial and error comes, and then one day you become succeed. In this way, mathematicians try various methods, and we got that if we take this kind of process, we got the same result. Have you got my point? So this is the one method to get the actual answer, because I have already told you that this ball, which is kicked by ball 3 Newton, by 3 Newton and the by 4 Newton, will must move in this direction, and answer must be 5 Newton. And this can be this answer can be taken by the process. Take these vectors tails at same point. Now draw a parallelogram. Now the diagonal gives the resultant value. So you can see here this appears like this, and now this is 90. So we can this is parallelogram. So this 4 also becomes this 4 and this 3. So it becomes 5. So answer is similar to this. Have you got my point? So now you can understand how this law, this rule, or this process works to find out the real answer when to add two vectors. So that is why this law, this rule, or this method is called parallelogram law or rule or method, because we have to construct a parallelogram here. There are another method also, triangle law or polygon rule of vector addition, or triangle rule of vector addition. But I am discussing the easiest, the parallelogram of vector addition. If you want to deep knowledge about something, or you want to know about the triangle or polygon rule, you can go for 11th class book in physics. So let us give you an example. Let us say this is a single force and denoted by F vector. I take a magnitude of F vector is 5 Newton and the direction is 30 degree, because I've already told you the angle is measured by some line which is called reference line. Here I take positive x-axis or a line which is called reference line, and the angle is 30 degree. So a vector can be a vector can be written as, this vector can be written as 5 Newton 30 degree east. Have you got my point? But it is written in geographical manner to find out the altitude and latitude. But in mathematics, how can we write, or in a symbol, or in a manner which we handle it? So we have already told that there is a different kind of vectors which deals the direction, which gives the direction. And I have already told you that if I draw a right angle triangle, it means it becomes H, it becomes P, and it becomes B. Can you find out P and B by using trigonometry? Yes, of course, you can find out. How can you find out? I have told you that P is equal to H into sine theta, and P is equal to H into cos theta. Here theta is equal to 30 degree, H equal to 5 Newton. Have you got my point? So P is equal to 5 sine 30 degree. If you remember, the value of sine 30 degree is 1 by 2, 5 by 2. And now B is equal to 5 cos 30 degree. It becomes 5 into root 3 by 2, means 5 root 3 by 2. Now our vector is actually resolved in two components, P and B. Yes or not? 5 by 2 and 5 root 3 by 2. And we can see here, if we want to know the real answer of our vector, then we take the Sulba Sutra, because here it is 90 degrees. So if you take H equal to root under P square plus B square, we got the same result, 5. Are you getting my point? That's why it acts as a diagonal for a parallelogram. Yes or not? In the Cartesian coordinate system, if you draw a parallelogram, it acts a diagonal. So here we already know that along y-axis, along positive axis, we assign a vector which gives direction, which is j cap. So if I take it towards y-axis, then this vector can be written as 5 by 2 j cap. Have you got my point? 5 by 2 is its magnitude. and j cap gives the idea about where it is situated in which direction. And similarly, it can be given by the vector 5 root 3 I cap, because you know that the in positive z axis, x axis, there is a direction vector which is called I cap, and its magnitude is 1. So if you multiply 1 in it, it is gives the same magnitude. I've already told you that this vector never changes the value of magnitude. It only gives the idea of direction. So we can write this vector as this and this. Have you got my point? So 5 Newton can also be written as the combined effect of p vector and p vector. Are you getting my point? So 5 Newton 30 degree east can be written as 5 root 3 by 2 I cap. Combined effect means plus 5 by 2 z cap. This is the another way of representing vector. We will deal it about it in your 11th and 12th class. It is very easy to handle the vectors. This type of method is very easy to handle the vectors. So what I have said you that if you draw a parallelogram, then a diagonal gives you the actual value of your vectors. So if I take two vectors, then the diagonal will give the real answer. Have you got my point? So I give you some problems. You have to solve it at your home. Try at home. TH. Find the resultant vector of these cases. First, 2 Newton, 3 Newton. Four Newton, 2 Newton. Three Newton. Another problem is Four Newton, 3 Newton, 2 Newton. Another 2 Newton, 3 Newton. Another is 5 Newton, 3 Newton, 2 Newton. You have to solve it at your home. Try it out. I am giving you some hint. How can you find the addition of these vectors, three vectors? First, try to resolve it in two vectors. For example, this is along the same line. This is larger. So if I forget about this for some moment, then the resultant of these two vectors must be 1 Newton towards east. Yes or not? So you replace two vectors by single vector, and you can now proceed the same process as I have told you. Now it becomes two vector. You can solve it out. Yes or not? By this similar fashion, you can solve these kind of problems. These are the cases which I have given you. The case of perpendicular vectors. In each questions, I have taken the angle 90 degree. Here, this is 90, this is 90, this is 90, this is 90, 90. So in every cases, I have taken 90 degrees so far. But what would happen when the angle is not taken as 90 degree? What would happen? So this kind of problem, we will discuss it in the next lecture in more detail. Thank you.